Welcome back to math. Today we are on module 2, lesson 5, and what we're going to talk about is making a visual model and using distributive property. Now if we have this from last time, this is called our tape diagram. What was the 5 stand for? That meant we had five boxes, and each box had how much? 21. So we put it like that, right? And do we remember what this equals? Well, 5 times 1 is? 5. And 5 times 2 is? 10. So it's 105 total, right? And that was what we called our, what is it called? Tape diagram, right. Now we're going to move on to the area model, okay? So let's talk about the area model. I'm going to make it real simple at first, okay? Let's talk about this. Well, normally we have what is called length and width. That means the length is the tall way and the width is the wide way. Does everybody understand that?
Yes.
Excellent. Let's move forward. How many boxes do I have going up the length way?
2.
I've got 2, so I can put a 2 here, okay? And how many boxes do I have the width or the wide way?
3.
We have 3, right? Because we have 1, 2, 3 boxes going, that would be wide, right? Or width. So let me get rid of those numbers. You can watch this again if you're drawing. Okay, now, and how many boxes do I have going vertically? I've got 1, 2, it's the length, right? So I have 2 boxes. Now, we could do it a couple of ways, couldn't we? What could we do? Well, we could say, I've got these 2 boxes here, right? And I'll change my colors so you can see the pattern, I guess. So what do I have? If I was drawing this, if I was going to write this out as an addition problem, I would have 2 plus 2 plus 2. Is that correct?
Yeah. Yep.
I've got 2 orange ones, 2 purple ones, 2 red ones, right? Does that make sense? And that would all equal what?
6.
6. So that's really the same thing as 2 times 3, isn't it?
Yeah.
Right?
Yes.
Okay. We have 3 2s, right? Somebody might actually write it like this. If you write it like this and you say, okay, we have 3 2s, that's fine. Is that better for you? That's okay. Now we can pull these off, and what I'm trying to get you to do is to understand the area model concept, okay? Now this time I'm going to put this one here, and let's put this one in green. Now what do I have? I have 3 this way, right? And I have 3 this way, right? 3 plus 3 is? 6. So I could say I have 2 boxes of 3, right? And that equals 6, doesn't it? So do you see how addition and multiplication are very similar, aren't they? Now, rather than writing our numbers out on the side like that, we could also do this. I'm going to pull those off. Let me try to pull all this color off of here. Didn't mean to do that. Okay. All right, so I can say I have 2 going this way, right? I've got 3 going this way. I can multiply these 2. So 3 times 2 equals 6, right? Is that correct?
Yeah.
How do we know that? Well, we can number our boxes. 1, 2, 3, 4, 5, 6. How many boxes do we have? We have 6 total boxes. Are you with me with that?
Yes.
Now this is an easy area model, okay? And what do we have to remember in our area model? What do we have to remember? Someone help me. Length times width, so I'll write that out. Length times width equals area. Or I could say, in this case, 2 times 3 equals 6. In this case, right? Okay. So it's a lot easier to do the multiplication, isn't it, rather than the adding, right? Okay, let's do another one. Do you want to? All right. Here we go. All right. So my question becomes, what's what? What is this? Is this width, length? This is length. Good job. And the one on the top that goes across, that's called width. And we know that length times width equals area, right? All right, so what's our L number? What's our length number? Well, let's see. We got 1, 2, 3, 4, 5, right? So our length number is 5. And what's our width number? 1, 2, 3, 4. Okay. So, right over here, what are we going to put right below the L? 5. Multiply. What are we going to put below the W?
4.
Right. So 5 times 4 is 20. And that's our area, is that right? And if we counted these, what do you think we're going to come up with? I bet you're right. 18, 19, and 20. We were right, weren't we? Now, these are easy, aren't they, so far? Now, what if we have bigger numbers? We had a lot bigger numbers. Let's say we have 23 times, let's make it 17. Well, we could use our area model to do the same thing, except we're not going to draw out 23 times 17, because 23 spaces down here would take a lot of room, wouldn't it? So how could we break this up? Well, we could say that this is our 3, and we could divide it here, and we could take our number here. What is that? Is that a 2? No, it's a 20. And then up on top, we could have our 17, right? We could do it that way. That'd be fine. So what's 3 times 7?
21.
Put our 1, carry our 2. 3 times 1 plus 2.
5.
So we have 51 here, right?
Yes.
Okay. Let's start with our 0. 0 times 17 is 0. 2 times 7,
14.
14. We're going to carry the 1. And 2 times 1 is
2.
plus 1,
33.
340. And now we're going to add them together because we broke them apart. It's 20 plus 3 equals 23, right? So 0 plus 1 is 1. 5 plus 4 is 9. And 3 plus 0, there's nothing there, right? Is 3. So our answer to our problem is 391. Now we can also do this, and this is 17 times 23, right? So let me just, so what if I took my 7 and I'll put my 10 here and I'll put my 23 up here, right? I could do it that way, can I?
Yes.
7 times 3 is 21, carry the 2. 7 times 2 plus 2. And 10 times, well, 0 times 23 is 0. 1 times 3 is 3. 1 times 2 is 2. And 0 plus 1 is 1. 6 plus 3 is 9. And 2 plus 1 is 3. This is the same number as we got up here. So you could do it either way and it'll still work. Does that make sense?
Yes.
All right, I hope that this is helpful. Go over it again as many times as you need, okay? I love math.